Hello and welcome to another video. This is the second video in my beginner's guide to Autodesk Bifrost. This video is going to focus on starting to use the Bifrost graph for the first time, how to get data into it, how to start connecting nodes together, and eventually we're going to end up building our very first Bifrost effect. Now, I'm inside Softimage now, and I've accumulated quite a lot of knowledge of Softimage over the years because I used to use the package quite extensively. And I've also used a lot of the ICE framework as well. And what I want to do is try and see if I can transpose some of that knowledge into trying to use Bifrost for the first time. And the reason for that is some of the underlying principles are still actually very much the same, even though ICE has now long since gone and Bifrost has taken over. And also, ICE is not necessarily Bifrost. They're not connected. There's no lines of code or shared technology to the best of my knowledge. But as I start doing this initial demo here now of an example I want to do, some of the underlying principles and workflows are still very similar. So if you're looking at this now and going, well, this looks very similar to Bifrost, then yeah, you'd be right, because some of the underlying principles are very much the same, or the paradigm, you might say. So what I've got here, I've got a very simple graph. I've connected some nodes and point positions, and now I can essentially now manipulate my torus object using the XYZ, and now I can start to plug in various things into this and start to manipulate it even more. So I can plug in, say, multiply my scalar node, for example, and then I can just add these various things together. And essentially what I'm aiming to do now is get to a point where I'm going to use these point normals, plug them in here, and what I've got is a very simple deformer, what was called in Softimage a push deformer. Now, there's not an equivalent deformer inside Maya, but the closest to it is essentially an extrude. So if you were to sort of select the entire object, or all the faces of an object in Maya, and do an extrude, it would do the same function as this. So I've just created this simple deformer very quickly as I've been talking now, and I want to see if I can essentially do the same thing in Bifrost and package the whole thing up in exactly the same way that I would do in Softimage. Okay, so we're ready to start now, and we're going to start to build our first graph. And I'm still learning as well, because I'm still relatively new to Bifrost, even though I'm an experienced Maya user. I haven't really dabbled in Bifrost that much. So I'm going to attempt to explain things in a very easy way so that you can follow along with me. And hopefully I'm not going to assume too much about your knowledge, because I want to assume that you don't know anything about visual programming whatsoever. Now we're going to try and recreate that deformer operator that I was able to do in Softimage very quickly. So we need an object, and we're going to use exactly the same object that we had there, which is a torus. And to give you an idea of what that would look like, the effect is, it's like if you were to take every face, for example, and then just do an extrude. And this is what it would look like. But obviously I don't want to do an extrude because I'm actually adding extra faces. I want to just do the same type of effect, but as a deformer. So that's where we're trying to aim for. A few things just to quickly bear in mind about Bifrost and how to understand it. It's important to understand how Maya works in terms of its data, and also what underpins objects as well, because so many people overlook this. And this is where you get things like the graphing and also the nodes inside Maya. And I'm not going to go through this in great depth. I just want to give you a very quick overview, because you go to the node editor, this is our torus shape, and this is where things start to actually happen or be created. And we can see if I just get 1, 2, 3 on my keyboard, I can expand all these things out. And many people overlook this because this is where, you know, this input node here is driving the mesh. So Maya is already nodal based in some way. It's just not as procedural based as something like Houdini. And with Bifrost, we can now expand upon the initial capabilities that are inside Maya and its dependency graph as well. And understanding about the objects and how it works is really key to Bifrost, and understanding the data that you have access to, and then the data that you can then manipulate. So let's now start to create our first Bifrost graph, and we're going to bring up the graph editor, and I'm not going to go through any fancy menus. I'm just going to use the Bifrost shelf and bring up the graph editor. Now, because I don't have anything selected, I get this welcome screen, and I've now got some options as to how to create a graph. I could do it here in this button highlighted blue, or I could do it from the menu here. I can also do it up here from the create menu, Bifrost graph. Now, because I've got nothing selected, I'm just going to jump straight in with creating a graph, and you get an output node and an input node. Now, the output node is really, before we do anything else, let's talk about what these nodes actually do. Now, the output node is essentially where everything goes to. This is the output for Bifrost, and when Bifrost essentially starts running all the nodes that you're going to plug into it. And I liken this to, like, say, the execute command in, say, a script editor. So if you've got the My Script editor and you type a mail or Python command, and then you choose execute, or you can just hit enter, for example, and that will run the script. And that's kind of what the output node is doing. Everything has to go into this until something goes into this port here on the output. Nothing really happens, or you don't really see the result of all the nodes you've connected. And this, again, we're in visual programming, and again, if you don't understand that paradigm and what that really means, it's you're putting commands together in the same way that lines of code work. Because again, in the script editor, all these things are part of our history. They are commands. They are creating certain things. You know, we can see here, we can see poly extrude, you know, set attribute, undo attribute, and these, you know, create polygon torus, and then it has the actual parameters here for the torus, and then you can select it. That's essentially what Bifrost is doing, except it does it in nodes. You're not having to write it all out. You join a bunch of nodes together with commands of what you want Bifrost to do, and then you tell what you want Bifrost to do, and then you execute it. So now we've understood that concept. We've got the input node now. This is what gets data from our scene into the graph. So we want to get this actual torus into our graph, but then how do we do that? And this is where it can be all too easy to trip up, even on the very first step, because there's no obvious way of doing it that I could see. There's no picking option. If we click on the input node, there's an info panel here which doesn't really say much. There's a parameters, but there's no select option. There's no drop down list. So how do you do it? So initially I thought, well, I'm just going to take the name and paste it in, and that kind of works, which is fine. But there's actually easier ways of doing it. If I just delete the graph, and that's just selecting the object. If you select the object and choose create graph, it automatically populates the input node for you. There we go. There's a torus 1 node and then the shape node. So that's kind of very straightforward. What you can do, that works the same way as if you do it through this editor, or if you do it via the create menu. The other way of doing it, which is even simpler, I can delete this input node anytime I want, and then take the object and middle mouse click drag it into the graph, and then it automatically populates as well. And it even puts the name here, which is not really relevant. You can just click this and name it to wherever you want. So I'm going to leave it as it is anyway, because then we kind of know what it is and what's been included in this input node. So we've got our torus object into our graph. What now? What do we do with it? Well, I guess you could say the first thing to do is you could output it to Bifrost. So you can literally just take the mesh and plug it in there. And does that do anything? Well, yes, it does. What it does is it tells Bifrost to essentially execute the shape, this mesh object, and it does that, and it recreates a whole new object. And at the moment you don't see it because it's sat directly on top of the torus object, which I'm going to call maybe the original object or the source object. But if I just move it off to one side, this is what we've got. So what Bifrost is doing is essentially using this original object, and you can see the differences because this has got a green wireframe when we select it. It's using this object as the template, as the source, and then we're taking all of that data into Bifrost, and then Bifrost is taking that data and then just outputting it, and it's outputting it to a whole new mesh. It creates a whole new mesh. And I'm going to call this the Bifrost object. Now, what data is being transmitted here we don't know at the moment. We can't see it, but we can actually see it now with Bifrost, because what we can do is we can just highlight over the line and right mouse click, and this will give you some options. And the main one we want is add Watchpoint. And what this has done is it's allowing us to visualize all the data that's on this line, this that's being transmitted, you could say, from the input node to the output node. Now you can see I can move this around and it always stays in the middle, but it's a bit awkward sometimes. But what you can do is click on the eye icon, left mouse click, and just drag it to where you want. So we'll put this over there, and we can see what is actually contained here. And this is showing all the data that's being transmitted through here to this output node. And you see it's made up of a number of components. We've got face components, and we've got offsets, vertexes, vertex components, vertex normals, UV, face vertex UVs. We've got point components, point normals, and positions. It's really important to look at this because, one, it's telling us what the property is here. It's given the property name. It's then telling us the data that is contained in that property and the type of data that it is. So in this example, we can see we've got 400 elements, 400 point normals on our object. And we've got 400 points on our object, which is the point positions. And we can tell it's an array, and the type of math that it uses is float 3. Now, I don't profess to know everything what that means, but I do know some basic concepts that I've picked up over the years. So this is where you will need to start grasping what this kind of means, because it is important, and you may not know it now, but the more you use Bifrost, the more you'll begin to understand what these things actually do. So an array in its most simplest form is a table or list of data. And this is telling us that there's a list of data made up of 400 elements. And those elements consist of float 3 values. And you can see what those values look like because this is what the default table is. And there's 3 values, 1, 2, and 3. This one is made up of 2 float values, which is why there's only 2 items there. And so what does that mean? But this is actually the points, all the vertices on the object, they're points. And we can see those points anyway. We can see them in Maya, even without Bifrost. If we were to go to our Windows General Editors Component Editor, and let's just say select all the verts, this is all the vert data. We can even see that in the channel box as well. If you select the verts, you'll see this CVs, and you click to show, and you get the same table here as well. That's a little bit awkward to see, but you can see it more clearly in the component editor. So this is really, if I just highlight these columns here, this is an array. It's a list or table of data, and the data contained within this array is point data, vertex data, and it each has, again, 3 values, 1 for X, 1 for Y, and 1 for Z or Z. We know there's 400 of them because we start at row 0, and down the very bottom there's 399, so 400. So this object is made up of 400 points, 400 vertices. Same with the normals. There's an X, Y, Z value. Again, 400 of them, 3 float values, X, Y, and Z. By looking at this in some very simple logic, we can begin to piece together what all these things kind of mean. Now, the other thing that you may notice is, well, hang on a minute. I'm just curious because I don't know anything about this. Why, if you've got 400 points here, vertices, but you've got 1600 face vertices there? How does that work? Surely that should say 400. Well, you'll be correct in understand that, but that's not kind of quite right. If we look at this polygon here, that one there, we know there's 4 vertices, but the vertices at the moment are all connected together. So actually, when I take this object and move it, there's only 1 vertice there. If I was to do a count, you'd see it's only 1 vert. If I was to separate every single face on this object, so that one, this one as well, then each face is going to require a vert. So therefore, this single vert splits into 4. So it's multiplied by 4. Same for every single vert here, which is why if I was to separate the faces, there'll be 1600 vertices, not 400, which is why we've got the count there. So that explains that, hopefully. Now we understand what these properties are, or we hopefully understand, what are we going to do with them? Well, we're going to manipulate them in some way. And what Bifrost is indicating here is that we know what to look for. It's telling us these are properties that we can actually bring into our Bifrost graph. Instead of actually going, what do I bring into? Well, you bring in these properties. You look for these properties and you do that through a series of nodes. Another thing to quickly highlight as well about this Bifrost object before we move forwards is that though I can move it independently, it's kind of connected to this like an instance. So again, if I move that around, it's connected, but it also moves independently. So again, it's like an instance geometry, and that's because it's using all the original data from this source mesh. So we want to manipulate the points because the points are really what create everything. They create the triangles and the faces. So that's the base data set that we really want to instruct Bifrost to access and then do something with it. So how do we do that? Well, this is where the danger is of making a little bit of an assumed knowledge, because you're going to go, well, what do I do now? I need to bring in some nodes, but I don't even know what node to look for. So this is where perhaps looking at the initial documentation is going to be handy. And I really do encourage you to do not overlook the documentation, because it does actually explain the fundamental concepts. And when the concept is getting data, you get data like a command, like get this, get that. That's no different to Bifrost. And to bring up the nodes, again, is a little bit confusing to some because there's no menu here. There's no node menu. There's no browser, which was slightly annoying to me because I wish there was a browser here and I could literally scroll through all the nodes, because that's what was in Softimage ICE, and it really was actually quite good. So the way to do it here is you hit the tab key, and this brings up this search function, and it works the same way as what the search function does in Maya. But of course, you can go through and browse all these as well if you want to. It's entirely down to you. But of course, if you're not going to know what to look for, then what do you do? So let's start off with point position. We want to get this property. So what we can do is we can filter by point. So if we type in point, this will filter out every single node that has point in it. But of course, how do you know which one to get? Do you get the point scope, or do you add points? So what you could do is put the entire property in. So it's point underscore position. And when I do that, there's only two nodes that you could possibly use. One is a get point position, one is a set point position, and they're kind of self-explanatory. You get the point position. So let's click that, and this node now appears in our graph. Now what we can do is look at the panel now on the right side. There's a parameter here, but also there's an info panel, and this has got a little bit of documentation to it. And it just tells you what it does. It says this returns the array of point positions for a geometric object. And it works with anything that's got points. So the input is the geometry that you want to get the point positions from, and the output is that point position data, this here. So we want to get the point positions from our torus. So what we can do is, let's just move this down here. We're going to take the output here, and I'm actually going to unplug it here and plug it down to there. Right. So, and the watch point has disappeared straight away, but we can bring it back. So what am I doing now? Well, what I'm doing is I'm taking that same amount of data that was going to the output node, and instead I'm driving it into the point position, except this node is going to go, well, I'm going to ignore all of that data and instead only get the point positions. So this is what this node is actually doing. Okay, so we've got point positions. What do we do? What do we want Bifrost to do with them? Because again, we're instructing Bifrost, we're telling Bifrost to do something with the data. Now, the next thing would be to say, well, why don't you just reproduce the data or set the data back onto the object? That would be logically correct. So we can go back to our tab again and go to point underscore position and bring in the second node, which is the set point position. And again, we can look at what the information says for that. And it says it sets the point position property to the values of the array. So if you remember, if we just check our watch point again, what it does is it sets this property here, right? But it uses data from here, and it uses data what we drive into it. So whatever data I push into this port, it will set that property onto our mesh, right? That kind of hopefully makes sense. So what I'm going to do, I'm going to take the point position and I'm just going to plug it into there. So now I've got the point positions, the data. I'm taking that data and putting it here. So this node's going to go, right, I can set that point position data. I'm going to take the data here. I'm going to plug it in and put it into the output. So I'll do this. Now that would be a natural thing to do, or to assume that would work, but it's not worked. Where's my object? I can still select it, still got translate values on there, but there's no object. What's going on here? Well, I started to think about this for a while and I couldn't work out, but because it's kind of staring me in the face because there's an extra port here that says geometry. The geometry input says any geometric object with points. And what's going on here is Bifrost is doing everything that you're telling it to do, with one exception. It's getting the point positions, yes, it's setting those point positions, but what's it setting the point positions on? It's setting it, it's just going to the output. It needs an object or geometry to actually set the point positions on. And this is the concept which I struggled with, believe it or not, early on, because when I was in Softimage, I didn't do this. It just worked. But the reason why it worked is because the graph was actually on the object itself. Whereas this original object, there's no Bifrost graph here. If I look in the attribute editor, there's nothing there that says Bifrost graph. So therefore, Bifrost has no concept of it. Bifrost needs to go, well, I'll set the point positions, but what geometry do you want to set the point positions on? So we want to set it on this source mesh, because that's what we're going to use to create the effect. So we need to take another arrow from here and plug it into the geometry here. And when we do that, we get an object. We get our Bifrost object back. So this was a concept I struggled with, and now I'm beginning to understand kind of why it's actually working. Because again, it's all about giving Bifrost instructions. Bifrost doesn't know anything. It's not going to assume anything. You need to kind of tell it what to do. So what we're telling it here is take the point positions from this object here and set them back onto the object and then execute here. But why would you do that? Why would you set data back onto an object which has already got it set? That makes no sense. Well, you do this because now we're going to manipulate that data. We've essentially branched that data off with this node here, and we're going to interrupt this data flow, and we're going to add a value to it, and we're going to manipulate it. We're going to change it. That's the underlying purpose of the deformer. It manipulates the mesh, and it manipulates the mesh by changing values of that mesh. And what we're going to do is we're going to change the point position values of that mesh. So what do we do? How do we do that? Then, well, a simple way of manipulating a mesh is adding a value to its data. So if we look in the channel box, for example, if I look in here and I've got X, Y, Z values, if I add a value of 2 to the Y, it moves it up. So I've taken the translation value of 0 and I've added a value of 2. So in theory, remember, we've got X, Y, Z value data here. And again, I can add a watch point to this and we can see that there. I should be able to add a value to those X, Y, and Z values, and that will change the point positions of those values of the object. So that's a simple maths function. And again, Bifrost is very good at that type of stuff. So we can look here and start looking at various different things. And if you start scrolling, you'll see things like math, and you've got lots of math functions here. But again, if you don't know what to look for, how do you know to even look here in the first place? So again, let the filtering take that hassle away from you and just apply logic to it. So you want to do some math. So you could put, say, math. That doesn't work. You could then say, well, what functions, what maths functions are there? Well, there's a multiply. So you could put multiply. So we can see there's a multiply node. So therefore, is there a subtraction? Yes, there is. So there must be an addition. And look, there it is, add. You can add points, but by reading that means I'm actually going to add points to the mesh when really I want to just add values to the points. So I'm just going to choose add. And we get this node straight away. So again, in the info panel, it says it very clearly. It just adds the input value. So we've got an input here, and then we can add another input, and it adds those two inputs together. And of course, the whatever that equals will go out the output, and we pump that into wherever we want. So what do we do here? Well, we want to take the original values of the point positions, which is here. Let's take them there and plug them into that. It doesn't matter if we've got them going here, because we can easily just override this by taking this and putting it into there. Like so that kind of, we don't have to unplug one and plug into another. If you plug in another thing, it can only take one input at a time into one port. So whatever you plug in, that will take priority. So nothing's happened here. So why is that? Well, all we're doing is a simple addition is made up of two values. You take value 1 and you add a second value. So value 1 is the original point position data, which is here, but we haven't added another value to it. So we need to do that now. And how do we do that? Well, we do that with another node, and we do that through a value node. So again, we look for value. And again, you're thinking, well, hang on a minute, how did you know it's a value node? Well, it's kind of there in staring at you. It says add the input values, one or more values, the value connected at the top of the node. So therefore, I just went, well, I'm in that case, it's telling me to add a value. So I'm going to look for the term value. And there it is. There's a value. There's got default value, absolute value, randomized value. So there we are. We have a value node. So now, if we look at the parameters here, we've got some things, boxes here I don't quite understand, but we've got a value, a number. So we plug that into there as our second part of our sum. Nothing's happened because it's set to 0. So if I was to say 5, my object is now moved, and it's moved in a really odd direction as well. Now we could just type in values, but if you hover over the actual box, you notice the icon changes these arrows, and if you hold down the left mouse button, you should be able to drag it, which is really good. The original Bifrost didn't have this. This is so much easier. Okay, so what's going on here? Well, what we're doing is we're adding the value of 4.327 to every single X, Y, Z value of the point positions. And I don't know why it's moving in an odd direction, but it's moving in a direction we don't want it to. So we need to change that. So let's get everything back to 0. So that's just applying a single value onto every single one of those X, Y, Z coordinates, the same value, which is fine, but at the same time, it's not good because it doesn't really deliver what we want. So how do we add independent values to X, Y, and Z? We need 3 values, 3 separate values. And there's no way of doing that here. Well, the reason is because the type of value doesn't match what the point position is expecting. And remember, if we go back to our watch point, the type of values it's looking for is, point position is a float 3. If we look at the node for this value, it's a single float. It just says type float. It doesn't say float 3. So already we've got a discrepancy, but it still works. I mean, it's not created an error. So we need to change that to say float 3. So how do you do that? Well, again, you can change it very easily in the node itself. You can just click this option here. You can also change it up here, but I'm going to do it here in this panel. So now you can change the value type. And again, without assuming your knowledge, what are you going to change it to? And how do you change it? Do you change it in here, matrix, vector? You could be asking, I don't know what a vector is. So already you're kind of stuck, right? Now I know what to change it to, but I'm not going to assume that you do. So let's cancel that. So what do I do now? You're kind of stuck already. But thankfully, Bifrost can help you out here. We just unplug this, drag that value over there out of the way. This is our input value. If we right click here, it will say create a value node. And when you do that, Bifrost very helpfully creates a value node in the same structure and format that the point position is expecting. And in this case, it's a float 3. So now if we look on our panel, it says type float 3. So this is perfect. We know exactly what it is. What you can then do is you can even look into the value type and see what it changed. And you can see here and compare it against what you had over here. So you can begin to piece it together yourself if you want to. So yeah, it's a float 3 value, and that's what we've got here. So now we've got 3 values, and if we drag in any of these values, it will change it in each one of the X, Y, Z coordinates. So this will translate in the X, in the Y, and also the Z or the Z. Okay, so that hopefully makes sense. So now we can manipulate the object, or correction, we're manipulating the points of the object because our translate values don't change. That is the main translation value for the object, not the actual point positions themselves. We're changing the point positions, not the actual object position. So how do we then scale that up? We're translating it. We're moving the positions, but we're not actually making them larger. We're not expanding the mesh. So how do we do that? Well, we kind of have to maybe scale it. And scaling is essentially multiplying values together. So maybe if we take the original point positions and multiply them by a value, then that will make the object bigger. So in other words, taking this and say, make it twice as big, multiply by 2, 3 times as big by 3, 4, 5, and so on. You get the idea. So let's do that. So we need a multiply node. Let's bring that to there. And this will work the same way as the add node. So therefore, I'm assuming right now, I should be able to replace this with this, because the multiply will start with the base values of the point positions, and then we're going to add what we're not going to add. We're going to multiply by this our normal value, just one value. So let's do that. So I'm going to take the point position data from here. Now, I don't need to add another point position node. I could just do this and connect it into there and then do it that way. But there's no point because this is already filtering it for me and I can have multiple outputs for it. So there's no point having an extra node there that you don't need. So that's done that. This is great. So now I'm going to take this value node over here. So let's plug that into that. So this is taking the original point position values and multiplying it by a value. Let's say 2. And then we should be able to take the sum of that and set that on here. So I should be able to replace it there. Cool. So now if I slide this, this should just make it bigger. Perfect. Okay, so logically that kind of works. Let's go back to 0. Oh, it's back to 0. We'll do 2, 1. Oh, okay, so that's why. If I multiply by 0, it is 0. So if I multiply by 1, it's 1. So, okay, that makes sense. That's simple basic times tables there. So it needs to always have to have a base value of 1 for it to appear. Okay, so just goes to show those maths that we learned when we were at school do actually come in handy. Right, so I guess technically we don't need this add node anymore. So I'm just going to unplug that. You know what, I'm going to put it over here out of the way because I might need it another time. Okay, so how do we then, we can multiply it uniformly and we can experiment a bit. Let's say if we took the value here. So if we were to take the same value, so actually I can Control C and Control paste that value because you can duplicate any one of the nodes. What happens if I plug that in? That'll be 0 because it's multiplied by 0. So we put 1, 1, 1. So now if we were to do it in the X, that will probably squash it a little bit. Yep. So, okay, now we're multiplying the values just along the X axis and then the... Okay, so we can get some morphing effect there. So it's kind of a deformer, a very primitive one, mind you, but it works. And then do the Z. Okay. So we've got the basis of something working. But we don't want to do 3 separate values. We'd rather keep it as 1. So let's just plug that back in there. So now we can multiply values and make the mesh larger. That works. We've got that working. So how do we create that effect that we had? Because if we bring in a new object, again, just to remind ourselves of what that deformer looked like, but it's scaling in a particular way. So how do we figure that out? Well, it's hard to figure out really, but what we could do is look at the normal data because the normals go out in a particular direction. So if we were to say, let's just undo that. And let's say we select that and choose our vertex normals. And also we could probably just highlight our face normals as well. So we can begin to see they go out in a certain direction. Now, if we were to do the extrude now, and again, it's just to mimic the actual effect, we can see that the normals kind of stay consistent. Because obviously this is we're in a negative extrude, but you can see what's happening there. If you follow the route of the normals. So if we were to multiply the values by the point normal position, that hopefully might give us the effect we're looking for. So let's do that. So let's get back here. Let's get rid of this object. So now we need to get the point normal position. And remember, we've got that point normal position there. So again, we can bring up our tab and let's go point underscore normal. There we go. Same two nodes as before, get point normal, set point normal. So we want to get point normal. And we need to give it some geometry to tell, so it knows which normals to get hold of. So we'll take that there and plug that there. Okay, so how's this going to work now? This isn't quite right, is it? Because if I unplug that, we've lost our object. So if I plug the normal into this, to there, and then we do that, and that's not working at all. So we just get a sphere. So, okay, what's gone wrong here? So clearly we've got no point positions. Can we add that into there? Oh, no, that doesn't work either. So already we've broken it. So what have I done wrong here? So even though I had it working here, what about if I add another port into here? So if I added the point normals, okay, so that's multiplying the positions by the point normals. That doesn't work either. So, okay, so what have I'm going to have to go back and think about how to do this now. So I've got the multiplication working, but actually I still need to retain the original point positions because it doesn't know what to multiply against and then add on top. Maybe I need the add node after all, because then the add node will just add the values together. So this is what we've got over here. So, okay, let's bring this back in here. So this rebuild it to what we had before. So we took the point positions and then we plugged them into there. And then we had the multiply. So multiply took the original point positions here, multiplied by a value there, and then we took that output and we added it to there. And that gives us the same effect we had before, except with this one, I can set it to 0 because I don't have to set it to 1 like I had to before, because it's already taken the base value of the point positions. That's already there. I'm then adding the multiplication to it. So, okay, that's why I can have it at 0 and not at 1. It's already got the initial point positions at their default values. Okay, that works. So now I can replace the point position here. So what I can do is if I unplug this now and instead use the point position to multiply, use the point normals. So let's take that there because we've got the base. Oh, that seems to have done it. And if we add a value into multiply it, and that should work. And there we go, we've got it. So let's just backtrack a little bit there and just review what we've done. Okay, so we've got our object. We've told BIFROST to get the point positions from that object. And then we told it to set the point positions on the object. But we've interrupted that data flow with an add node, and we want to add a value to the original point positions. Now, whatever value we add is going to be the basis of an equation. We could do a simple add equation, and that will move its point positions in the X, Y, and Z. But the equation we want to use is a multiplication. And in that way, we can make the object larger and expand the object in a particular way. If we use a simple multiply, so let's do a little bit of rebuilding here. Let's do a multiply. So if we take the original point positions and take a very simple value, So if we take the basic point positions as they are and we multiply them by a value here, we'll just make the entire object bigger, because we're not changing the structure of the array. We're not growing it. We're just making it all uniformly larger, which is a scale. Because we're multiplying it by a single value. We're multiplying every single XYZ position by a single value. So this is what this operator does here. These two nodes do here. Now, what we've done is decide to replace that and say, well, actually, don't take the point position data as a baseline because you've got it here already. What we want to do is take the normal information, which we know is going to be here, which is slightly different, but it's all coming from the point anyway. So we want to take that and we want to multiply that instead by a value. So instead of taking the point position data, we're going to take the point normal data, which is what we've done here. So we've got the same multiply, and instead of directing the point positions in, we're directing point normal data instead. And then we're taking a single value here, whatever that value may be, and we're multiplying the base point normal data by a value. And then we're going to take that, that sum, the result of that sum, and instead of adding, and we're going to add it here. So this, let's take this and unplug that. And instead we're going to take this and plug it into there. So we're taking the result of this multiplication and we're going to add it to the original point positions of the object. And then once that's done, we're going to tell Bifrost to set those point positions and then execute. And that's what we've done. So that's what creates our deformer. And again, we can just unplug this and move this over here out of the way. So when we just piece it together, let's make it a little bit more neat and tidy, we've got our first Bifrost graph. And we've been able to recreate a push deformer. So this is it. This is your first Bifrost graph. I hope you've been able to follow along with me. And hopefully at the end of it, you've got the same result that I have. And you've now created your first push operator in your first Bifrost graph. So this is the end of this first video. I hope that was really useful to you. I hope I've been able to explain it in a very simple way and you've been able to understand the concept of how I've been able to piece it together. In the next video, we're going to expand upon this and we're going to look about how to package this up as a compound so that you can distribute it or you can save it for future use. Thanks for watching and I'll see you in the next video.